So metal nuclei are positively charged, however they are found to be closely packed in metal substances. What stops the ions from repelling each other? Each of the ions is really closely packed together, but how come they don't just repel each other and destroy the crystal? Well, the delocalized electrons move through the lattice and attract adjacent metal ions. If there's an ion here and an ion here, if an electron goes past, the electron goes whizzing through, it will actually attract both of these together, obviously, because if a negative charge is in the middle, obviously they'll attract to one another. So that's what the first statement is saying. Now this stops the structure from breaking apart because the repulsion of the nuclei is now sort of counteracted by the attraction to these electrons. The repulsion, because of the positive charge, is actually counteracted by the fact that you've got all these electrons randomly distributed throughout the material, which helps to hold the lattice together. Very fine game that we're playing with metals, that each thing is sort of nicely balanced with the next. So explain why delocalized electrons lead to excellent electrical conductivity. So electrical current is the movement of charge through a substance. That's what electric current is. Since there are many free charges in metals due to the delocalized electrons, because there's lots of them, large electrical current can be generated because all of them are free to move, and so that's why delocalized electrons give metals excellent electrically conductive properties. Now, that was electricity, but what about heat? Metals are really good at conducting heat. If you, for instance, put a metal spoon in boiling water, you don't want to touch that spoon about a minute later because you'll burn yourself. That obviously shows us that metals are good at conducting heat, but why? So heat is transferred through a metal by vibrations. If you've got one ion being heated up, it will shake like this. Now if there's another one sitting here, it'll continually bump into this other ion, like a really annoying bus passenger or something. And then this one will start vibrating. And then that will keep going, sort of like a chain effect, down so that all of the ions are actually vibrating. Now since the metal atoms are close together, vibrations can be passed very easily to one another. So imagine if I was standing here with someone standing here. If I was to start shaking, they would just be fine. But if we were right up next to each other, then if I started shaking, they would start shaking as well, because just to get out of the way. The fact that they're so close together means that vibrations can be easily passed along from one atom to another. Now, another reason why they're good at conducting heat is the fact that the delocalized electrons also help to transfer heat as their motion is increased due to the fact that there's heat energy around. So an electron moving around might bump into an ion and make that start vibrating. So you can see that if you've got a lot of electrons around, there'd be lots of collisions and lots of shaking, and the heat will get transferred very rapidly, in addition to all these other vibrations happening through the lattice. That helps. This means they are likely to collide with metal ions, creating more vibrations, as I mentioned. Question 9, why are metals malleable? Answer with regard to metallic bonding. Well, due to the close packing of atoms, layers of metal nuclei can actually pass over one another. And the strong attraction between the metal ions and the delocalized electrons stops these layers of metal nuclei from completely detaching, and thus allow the metal to retain its shape. So as they slide along, they still are held to the other atoms. It's just that they've been moved along by a force, and so the actual metallic bond helps to hold the metal in shape as we change its new shape. So question 10, metals are considered to have a high boiling and melting point. Explain why this is so. Okay, so why would metals have a high boiling or melting point? The attraction between metal nuclei and electrons form a very strong electrostatic attraction. So when you have the nuclei of the metal, you've got these very big positive charges, and you've got all these negative charges swirling around them. So the attraction between those two is very, very strong. And that ensures that the metal nuclei are kept in the same place rigidly. So the metal nuclei are always held in place by these electrons and protons. Therefore, in order to melt the metal, high temperatures are required to overcome the strong force of attraction between the metal ions and the electrons. So that concludes today's lesson on metallic bonding and metals. We looked at what metallic bonding is, and we explained the properties of metals through the metallic bonding model. Okay? So hopefully you've learned something about how metals operate, and I look forward to seeing you at our next lesson.